All right, thank you, Jim. We are moving forward rather quickly in some of these little breaks. We had some power outages that affected our first session, so we got behind a little bit. But we're going to move up, and but we're going to also make sure that you get the full value of each session. Now, please, if you are watching this on the net in our live stream, scroll down to the bottom of where your live stream is, and you'll see an opportunity to enter questions. So if you have any questions you'd like to ask, go ahead and go down to the bottom of that. Put your cursor in the ask a question box and ask your question and submit it. And we will get some Q&A at the end of this session. So twins, what do we know about twins? I've got twin grandchildren. They were born on my wife's birthday, which was the day after my anniversary. So things get rather hectic around our house that time of year, August 13th and 14th. But the twins, we have one boy and one girl, one named Serenity and Jeremiah. But they're fraternal, so they are a little bit different. Each is different. So one thing to remember as we start thinking about Apollo and Artemis, even though they are mythological twins, they are both somewhat different. And we should not expect one to be the other or one to reflect the other than taking the strength from the previous one and moving forward. Our session today is about those twins and how Artemis, this twin, will go further, we hope, and longer, we hope. Our moderator is Erika Alvarez. She's the Acting Systems Engineering and Integration Director for Advanced Exploration Systems for NASA Headquarters. Erika, take it over and introduce your panel, please.
Thank you, Alan. Once again, we are here today and very excited to be talking about Artemis 1. We are making incredible strides every day as we're preparing for all our green run checkout tests down at Stennis Space Center. We are getting all the hardware together at the Kennedy Space Center, and I know that we have all the facilities ready to go to support Artemis 1. As well as we have a lot of work right now with Artemis 2, where we're sending our crew further than we ever have before. And in Artemis 3, we're going to have the first woman that actually lands on the moon and the next man. Part of the panel today, why I'm really excited to be here, is because we have a diverse group that is here to talk about the new generational aspects of what it means to be part of the Artemis generation. Each person that is here that will share with you today what they're doing, what the innovations are, and what the experience is like to be a part of this has a unique perspective, different expertise. And what you'll find is that as we get a little bit into some of the discussion, everyone right now is just extremely excited to be a part of this venture. Also, we have a few fun things for you, a couple of social media campaigns, some personal questions where, I did ask the group to provide what they would like to pack if they were on a trip to the moon. So I know right now we have a big campaign that you can submit through Instagram, Facebook, even Twitter to upload and use a hashtag NASA Moon Kit of what you personally would like to provide. So without any further ado, I'm going to go ahead and introduce our panel. We have Caite Beck. Caite is the Principal Structural Design and Engineer at Northrop Grumman Space Systems. We also have Tony Castilleja from the Boeing Company. He's a systems engineer at Boeing. Jonathan Pahed is also here. He is a lead engineer for the RS-25 engine main combustion chamber at Aerojet Rocketdyne. Eric Weaver is also a senior manager in engineering analysis at the Jacob Space Operations Group. And Mary Pope, who is our project engineer and staff for Lockheed Martin Space. So without further ado, I'd like them to each give a presentation on what they're doing in their respective areas, and then we'll get into our discussion. If we can go to the next slide, please.
All right, so I will get started for you guys today. Again, as Erika said, my name is Caite Beck. I'm a principal structural design engineer for Northrop Grumman, and I'm located out in Promontory, Utah. I'm really excited to be talking to you all today. Thank you again for having me and for AAS for putting this on. It's great event so far. So Northrop Grumman supports NASA's Artemis program by developing and manufacturing the 2 solid rocket boosters that you can see on the graphic on the left of the screen for the NASA Space Launch System. And these boosters are a 5-segment motor with the aft assembly with their thrust vector control and the forward assembly with their avionics suite. And we also do the booster separation motors, which there is 8 per booster, 4 on the forward side and 4 on the aft skirt. We also support KSC integration and support in Florida. And we actually just completed our 5-segment motor qualification in 2016 and had an additional successful Flight System Booster 1 static test in September, which is the photo that you see, the large photo on the bottom. And this static test, what you're actually witnessing in that photo is 3.6 million pounds of max thrust and a burn time of just over 2 minutes. So as they were mentioning earlier, we are more than capable to be able to get humans further than they've ever been before with the amount of power that you can see in these 5-segment motors. You can go to the next slide. So what you see in this slide in the bottom left is actually me working on that Flight System Booster 1 static test disassembly. So after we do the static fire, we have to take apart the 5 different segments and make sure that the joints and seals operated in the manner in which we expect them to. And that's what I ended up doing in this particular photo. It's a flashlight in my hand while I'm looking at the seal surface. So these SLS boosters provide more than 7 million pounds of thrust at liftoff. And as I said, that's going to be the largest human-rated solid rocket boosters that have been ever built for flight. So that's why we're sitting there making sure that it's operating in the way that we expect, so that we can definitely get our humans and our astronauts there safely. These things, as I mentioned before, are massive. They're 177 feet in length from tip to nozzle, and they are 12 feet in diameter. So that's why it looks in that close-up photo of me against the joint. It may not necessarily be extremely clear what it is I'm looking at, but I'm pretty short. I'm only 5'2". So in the 12-foot diameter, you got to kind of zoom in to be able to see me next to the large motor itself. In the top left photo, we have our launch abort motor, which is part of our Orion launch abort system. And then like I said before, we're just making sure that SLS is going to be safe and affordable and sustainable so that it can be used for both crew and cargo missions. You can go to the next slide. So moving forward, we have some significant accomplishments that we're excited about. Our booster segments for Artemis 1 are currently at KSC, and the booster stacking is currently planned to start at the end of November. And you can see that picture in the bottom right of the segments. The abort motor is integral to the launch abort system, as I said previously, and it can safely remove the Orion crew capsule at any time during launch and ascent through the LAS jettison. And you can see that test flight on the bottom right photo. And then in addition, we're working on our booster obsolescence life extension or BOLE program, which is currently slated to begin with Artemis Flight Set 9. And this BOLE program will enable uninterrupted access to deep space by resolving any obsolescence of the legacy shuttle hardware. It leverages our Northrop Grumman investments to support national security launches, which will include increases to overall performance. And we're increasing that performance through planned design improvements. And this BOLE program will empower our lunar and Mars campaign to allow us to go forward to the moon and beyond. And then I have the honor of working on the case design for this BOLE program. So I'm really excited to see that progress and move forward as well. So with that, that's it for Northrop Grumman, and I will hand it off.
Well, again, good morning, good afternoon, everyone. My name is Castilleja. I'm here and been working with our great team at Boeing on the core stage. And it really does take an entire aerospace team from across this country to deliver a tremendous first core stage for the Artemis mission. This is flight hardware. And when we build this hardware the first time, we're going through what we call a green run test. Green means that it's green. It hasn't been used yet through the full operational element. We've done design, we've done analysis, we've delivered the first Artemis core stage, and it's now at the B2 test stand in Stennis Space Center down in Mississippi. And so it's just a testament to go through all of a full suite of tests during this green run test since it's arrived soon after January of this year down at Stennis Space Center. And so this team has persevered, has endured. It just shows just the passion that we have to go through every single day and take this flight hardware to flight ready status at the completion of the green run testing. Anything from turning on the flight computers, going through a variety of systems checkouts, being highlighted with the 8 full tests that occur for the full system, but every day is just a testament of not only delivering the core stage and going through all these flight checkouts, but also setting the culture of what it's going to be like to take the first rocket that will go further than its twin, the Apollo rocket, right to the moon and back, uncrewed this first one and then 3 missions afterwards. And so when I look at that test stand, you know, I worked on the space shuttle program. I worked in mission evaluation rooms, and it's just an exciting time because you see an unlocking of an initial operational capability of this rocket for this new Artemis generation. And I'll tell you, that's a big deal. And it's a big rocket, 212 feet tall. The test stand over there in Mississippi, 35 stories tall altogether. It's a pretty tall item. And when we are going, as we progress through the highlight of the green run testing procedures, which is the hot fire test, well, this is the first rocket that will actually go, that will actually deliver Orion to go around the moon. And we don't want it to go anywhere in this test. So we got to strap it down on this test stand and go for the full more than 1 million pounds of thrust to our Aerojet Rocketdyne friends, those RS-25 engines that we'll share more about with my friend Jonathan here in a little bit. But a tremendous integration and just a fantastic teaming between Boeing, NASA, and all of the aerospace partners here today, making great progress. And to see the engines on the lower right there, gimbal, boy, it just shows you that this rocket is getting ready for first flight. Next slide. And it just stopped. You know, behind me, you'll see a 5 Lego rocket inspired by those missions as a hobby myself. But I have the SLS on my other side. Well, the twin approach doesn't just stop there. There are identical twins of Artemis 1 and Artemis 2 already in the Michoud assembly facility in New Orleans, Louisiana. You know, there's a vibrancy and a passion and a physically distanced way these days at the Michoud assembly facility of dedication to this rocket. For Artemis 2, which is that core stage again that we'll be delivering, this Artemis 2 core stage will go from Michoud assembly facility and then go straight to Kennedy Space Center in Florida. All the tanks, the intertank, the engine section are all at Michoud assembly facility and coming together. 48 states and suppliers from across the country deliver raw material on one side of Michoud assembly facility, and the rocket builders of our generation, taking all those lessons learned and best practices from this factory that has a storied history from building space shuttle external tanks, taking it to this next level, building the brains of the rocket there at Michoud assembly facility. Artemis 2 hardware all coming together, and you'll be seeing Artemis 2 being delivered. But at the same time, its twin, Artemis 3, the first rocket that will launch, the first woman will land on the moon, and the next man for humanity is already in production at Michoud assembly facility. And then you have Artemis 4 parts being ordered. It just shows you the commitment of a nation. And more importantly, when we're talking about this generation's rocket, we are also, when you look at the amount of work that's going through Michoud assembly facility, we're going this time to stay. There's a sustainability to it. And critical to that is the production system. And so we've got 8.4 meter, which is the diameter of that core stage tooling throughout the factory, putting out that throughput. Our team is getting just better and better with Artemis 2 and Artemis 3. And so you're seeing just tremendous efficiencies of America's rocket factory. It really is the factory of that future, and that future is today. And as we go to the next slide, it's all about an American capability for a super heavy lift rocket. This is the only second time in our nation's history that will be having the 45 metric ton of translunar injection capability. That's a big deal. It's a heavy lift, and it's a heavy lift that has been lifted by this great workforce from across the country. We call it the Space Launch System, but I like to call it the Space Line System. It's going to give us a direct line with the Orion spacecraft to the moon and back, leveraging the gateway to give us unprecedented access to the surface of the moon. Just in the last hour, right, the NASA, there is water on unlit surface on the lunar surface. There's so much to learn every single day, and that super heavy lift capability gives you 8.4 meter size, 45 metric ton, 42 metric ton capability, co-manifested capabilities with the Orion spacecraft with humans, as well as science payloads behind you of 10 to up to 12 metric tons to land you to the surface of the moon to unlock tremendous science and discovery. And we just rev it up. You're going to hear from Aerojet Rocketdyne on their rated power levels, but we rev up the science. And so that's not just only for the moon, but it goes onward to Mars and throughout the solar system with more than 3 times the heavy lift capability, 3 times the power than any other rocket out there today. So when I think about what I get to do when I wake up every day, this isn't my grandfather's rocket, this is our generation's rocket. And when you look across our team, you see the most diverse generation. That's the Artemis generation. So thanks, and we'll hand it over to Jonathan, Aerojet Rocketdyne.
Thanks, Tony. Of course, as Katie touched on, we had all that solid rocket propulsion, but along with that solid rocket propulsion, we have all the SLS liquid propulsion, of course. And Tony touched on the core of the SLS, which is the 4 RS-25 engines. For Artemis 1, they've been integrated into that core stage, and as he noted, we're excited and ready to go, and we're waiting for green run. And the rest of the SLS propulsion has been integrated and is ready to go as well. We have the upper stage engine with RL-10 and the ICPS that's integrated, as you see in the top left, and is ready for flight. And all the Orion propulsion, the Orion main, the 8 auxiliary engines, the LES jettison motor, the RCS, those have been integrated into Orion and are ready for flight as well. And next slide, please. But along with Artemis 1, how about Artemis 2 and beyond? As many people know, for Artemis 2 and beyond, for the first 4 flights, we'll be using 14 engines for RS-25 from shuttle days, along with 2 additional engines. But we'll be taking those engines further than we did during shuttle. We'll be taking them to 109% power level versus the 104% power level that we had during shuttle days. And we've retrofitted them with a new controller, new installation, and we'll be taking each engine to more than 500,000 pounds of thrust each, powering that core stage. And for RL-10, as you see in the top left corner, along with Artemis 1, for Artemis 2 missions and Artemis 3 missions, we're ready to go. But we're expanding upon that legacy that we have in RS-25, that legacy of that reliability, of that 1.1 million seconds of hot fire time. For Artemis 5, we'll be building new engines and implementing new material processes and technology to expand on that affordability and sustainability that Tony and Katie touched on. Like, for instance, in the top right corner, you see the Pogo accumulator, where we're able to manufacture that with additive manufacturing. And then the main combustion chamber you see in the bottom right corner, which I myself had the opportunity to be the team lead on for the past 6 years. We implemented new processes like hit bonding, as opposed to the nickel buildup and large amounts of welding that we did during shuttle days to make the main combustion chamber. That was very arduous and time consuming. And in the new main combustion chamber, we've been able to actually reduce the time and the cost to make the main combustion chamber by 10%. And in the bottom left corner, you see the famous nozzle of RS-25 that is famously seen on the back of the space shuttle. The jacket of the space shuttle that has always been seen in all those famous pictures previously was made with 37 welded pieces. We've taken those 37 welded pieces and reduced those to 4 large cones that have been welded together, and we'll be able to machine those and precision machine those that will improve the affordability and the consistency of our parts for the future. Next slide, please. But Block 1 and Artemis 1 is just the beginning, as Tony was noting. This will be the foundation for a generation of deep exploration from from now and for the foreseeable future. Just for instance, in terms of the upper stage, for the exploration upper stage, we'll be able to implement 4 all-10 engines. And for the new R75 engines that I touched on earlier, we'll be able to take that 109% power level that we'll be using on the first 4 flights and take that to 111% power level. And again, as Tony noted earlier, that will allow us in Block 2 to have 445 metric tons of payload capability. This is far more than capable than any other rocket that's being used today. And now let's go ahead and move over to my friend Eric.
All right. Thanks for the handoff, Jonathan. So thank you again, everybody. And I'm really excited to be invited here to talk about some of my work at the Kennedy Space Center. As the Senior Manager of Engineering Analysis, my departments are responsible for all the technical analysis that it takes to receive, process, transport, stack, and subsequently launch SLS. And we get our hands on basically every piece of flight hardware that you see in this image. And from the first time that it arrives at the Space Center to the moment that it leaves Earth on its long journey. So that's very rewarding for both myself and my team. And despite the pandemic, nearly all of the flight hardware components that make up SLS, are the largest rocket ever built, are primed and ready to go at KSC. Only the SLS core stage remains to be received at Kennedy Space Center, and it's due to arrive this December. In fact, solid rocket booster segments are set to start stacking in the vehicle assembly building next month. And through all the preparation leading up to this critical juncture where we actually start stacking the rocket, we've been able to come up with many smarter, more efficient, and affordable ways to do business. And hopefully some of the subsequent slides will highlight some of those. So next slide. So I'll start with the core stage. And so the core stage and its associated ground support equipment is actually going to be the heaviest piece of flight hardware, the heaviest thing ever taken into the transfer aisle of the vehicle assembly building. So in order to prove the facility could handle such a heavy load, new, more accurate analysis methods were developed using high fidelity 3D finite element models of the concrete floor itself. The original analysis methods used during the Apollo era in the 1960s wouldn't have been able to show us that the floor could actually handle such a heavy load of the core stage and its associated ground support equipment. So these improved analysis methodologies help save the program tens of millions of dollars in potentially very expensive facility floor modifications to support the heavy load of the core stage. And EGS is only about 13% of the total program budget, about $590 million from Congress in 2020. However, we're always looking for more ways to gain efficiencies and reduce costs, like through the implementation of the new oil pharmacy, which services many of the cranes and mechanical equipment that you see here in this photo. The new oil pharmacy, which uses condition-based monitoring, as opposed to sometimes more wasteful time-based monitoring, has saved over 11,500 gallons of oil and $5.1 million to the program to date, all while keeping equipment running at their intended functional capacity. So, next slide. At Pad 39B, construction is underway for a 1.5 million gallon liquid hydrogen tank, which helps provide liquid fuel to the core stage. This new liquid hydrogen tank will give the program capacity for additional scrub turnarounds, which was not previously possible, saving time and increasing capability to the program to hit those small launch windows of future Artemis missions. In addition, Jacobs has developed the software in the firing rooms of the Launch Control Center. There's about 50 ground systems, multiple vehicle systems, independent avionics, and flight software governing each vehicle element. And throughout the development phase, the team really leaned forward to think of new innovative tools and methodologies to save time and build confidence in the products. For example, development of automated tools, such as an automated code generator to automatically build applications and displays, and automated testing of the system has saved thousands of man hours and months off the development schedule. Next slide. And finally, engineers at Kennedy Space Center are also responsible for many aspects of landing and recovery, which includes all new recovery methods, hardware, and periodic missions with the US Navy to test all these new means and methods. a state-of-the-art wave monitoring system used by KSC ocean engineers to make recommendations to NASA and the US Navy on the ideal location and ship heading for Orion capsule retrieval is also used. Additionally, instead of using cranes to more or less fish the capsule out of the ocean, which was more or less done during Apollo, a winch, tow pin, bumper, and line attenuating system, kind of like what you see here, is used to actually tow the capsule into the back of an open well-deck US Navy ship. EGS is responsible for all of the engineering, operation, and maintenance for all of the equipment that is used during retrieval missions that you see here, all to more safely and effectively bring the astronauts home from their very long journey. So, and just to wrap it up, I mean, we're so close to stacking and launching the largest rocket in human history. The mobile launcher is out at pad 39B right now on its final washdown, and then it'll be moved back in the vehicle assembly building just this weekend or next week, and in order to start stacking. So personally, I really couldn't be more excited for the launch of Artemis 1 next year and for whatever's to come beyond Artemis 1. So thanks, and hand it off to the next guy.
Thanks,
Or
Eric.
girl.
Hi, my name is Mary Pope, and I'm currently the technical assistant to Lisa Callahan, our vice president and general manager of commercial civil space here at Lockheed Martin. Prior to this role, I worked on Orion propulsion for over 4 years. I worked on hardware that's been integrated on Artemis 1, the vehicle on the left that's going to fly uncrewed around the moon and come back to Earth. Artemis 2 in the middle, that's going to take humans further than they've ever gone before. You can see in the middle picture that the crew module windows have been installed. The next time a human looks back at Earth as a little blue dot from the lunar orbit, it's going to be looking through those exact windows. I also worked to develop hardware for Artemis 3, which is the mission that's going to take the first woman down to the surface of the moon. I'm really excited to participate in this panel, but I do wish it was in person because I actually grew up in Huntsville, Alabama, and I always love a reason to go back home. It's been really exciting getting to work on Orion and watch it grow into a long-term exploration program. My dad actually works at NASA at Marshall Space Flight Center, and I grew up constantly surrounded by all the possibilities that exist in space. Orion is the most advanced spacecraft to have ever flown and the most reliable. It's the first human-rated spacecraft built with the tools of my generation, like our digital twin technology, advanced onboard electronics, and augmented reality, which we use in many ways, including during manufacturing and assembly. For instance, by using AR, we've reduced the crew seat assembly time from 8 hours down to just 45 minutes. Can we go to the next slide? There are quite a few challenges to exploring beyond the moon and onto Mars, which haven't been dealt with before. Protecting our crew is our first priority, but then giving them the tools needed to explore our solar system with confidence is key. Just to give you an idea of what Orion is capable of, on the left is what a trip to the ISS encompasses, but the missions in the middle and on the right are what Orion was made for. Even just going to the moon is orders of magnitude harder than going to the ISS, and going to Mars is on another level entirely. Orion is the first spacecraft designed with human-rated requirements to protect the astronauts on board from radiation, which is needed for short duration trips to the moon, but even more essential for longer trips to Mars. All of the spacecraft before were primarily designed to protect the equipment, and now our primary focus is on the crew. Since its inception, Orion has continuously evaluated and incorporated new technologies, like closed-loop life support systems, thermal, micrometeorite, and radiation protection, like I just mentioned, and a communication system that uses GPS signals from the spacecraft and optical comms technology to allow for multi-gigabit data connections back to Earth at a rate that's 1,000 times faster than the shuttle and ISS data networks. That high-definition video that our communication system will send back is how the rest of us get to go along for the ride. All of these technologies and capabilities have been extensively tested, and we've involved the crew along the entire process, getting their feedback and making sure that their needs are met so that they can go on these deep space journeys safely. Deep space is hard, and there will be unexpected challenges, but we're ready to face them. With abort options that can get the crew back home to Earth in a matter of hours, even when they're all the way out at the moon, to being able to survive a micrometeorite hit and still keep the crew safe and get them back home, Orion is ready to take us farther than we've ever gone. and get those on board home safe so that they can share their stories firsthand. Can we go to the next slide? One of Orion's greatest strengths is its ability to leverage all of Lockheed Martin's experience from all of our other missions and our know-how when it comes to passing down information and lessons learned to new generations. We've been so successful on our robotic deep space exploration missions because we've been doing just that and leveraging our investments across the board since 1976. It's in part how just last week, our OSIRIS-REx robotic spacecraft was able to perform a touch and go sample acquisition from the asteroid Bennu, which is over 200 million miles away. If you haven't had a chance to learn about that mission and recent accomplishment, I highly recommend checking it out. NASA actually just posted a compilation video of the TAG event to their social media channels yesterday, and it looks really cool. Just like NASA is leveraging the shuttle main engines and boosters, we're leveraging technologies from across our portfolio. For example, Orion's fault detection and management system is built on the backbones of the fault detection system used on our robotic planetary missions. Natural feature tracking that was used on OSIRIS-REx will be fed forward to the lunar lander's hazard avoidance system. I personally have a passion for exploration in all areas of my life and a desire to push the boundaries of what's possible. To know that I'm a part of the program that's going to take the first woman to the moon is so fulfilling, and to know that when she gets there, she's going to have more tools and technologies at her disposal than ever before, allowing her to increase our knowledge about our solar system and what's out there in the beyond. I'm going to get to be there for every step of her journey, and I can't wait. All right, back to you, Erika.
So one thing that I asked the panel to do as part of really seeing how much that they own the Artemis missions and that their personal fingerprints are actually a part of all the hardware, the design, the analysis, the testing, the development, and the launch of the systems. One thing that I asked each person to do, and I know we had a graphic that might have been on the last slide, is I asked them, what are the things that if you were to pack something to take on the moon, what would you take with you? So I think Tony Castilleja may have shared something, as well as Caite, some images that were in the PowerPoint.
Sure, let's see if it comes up. Otherwise, you know, there's beauty in words, right? So I think, yeah, mine's over on the bottom right. Hashtag NASA Moon Kit. You know, you have to summarize your thoughts in 240 characters or less. Go to the moon. So with that kind of approach, number one, you know, this rocket, it's a super heavy lift, and you know we can take a lot of stuff. With that kind of mindset, have a little fun from the engineering side. The creativity came through. There you see the viola. I'm a violist. Let me just be very clear. Engineers are people too. And that kind of creative spark that drives to the innovations that we're putting into our engines, to the core stage, to everything that we're doing. And when another person might notice the NASA worm, right? I'm an art. There's a art item there on the lower right, and so got to bring that along as well. But one can never forget coffee, and not only leverage to the cold brew, if you will, of the space stations and never-ending work that foundationally we're all learning from for deep space missions, and be able to make yesterday's coffee, today's coffee, and tomorrow's coffee. But more importantly, the focus on that environmental sustainability. And the important thing here is that SLS can take the big stuff you need, whether it's going to the moon or going to deep space in really half the time and the simplest mission scenarios you can ever see. So a little bit of inspiration out there. Somewhere out there, we're going to find a new life. And boy, we got to pack up and be ready for it. And this is the rocket to do it.
And then I see Caite. Caite also shared her NASA Moon Kit. I don't know if Caite wants to talk about what she has packed here.
Yeah, of course. First off, can you guys hear me? For having some technical difficulties on my side.
Yes, we can hear you.
Oh, wonderful. Okay, great. So I would bring I have a small journal. I'm very much a write it down type person to remember everything. So I'm always jotting notes. I'm always making sure that I'm keeping track of all of my thoughts. So I would definitely need to bring that. I brought an e-reader because I'm, again, always reading and want to make sure that I can still have time to read books from the space station. I have a USB drive with music to listen to. And then you guys probably noticed this, I have red hair. I burn very easily. So without having that extra layer of ozone to protect me from the space station, I said I definitely need to bring some extra sunblock for me. And then finally, I would obviously bring pictures of my family and my husband, who have been incredibly supportive of me to get to where I am today. And in this hypothetical world of me being on the space station, would also have been in the same level of support. I try to maintain the size limitations that are given by NASA, the 5-inch by 8-inch by 2-inch, and to the best of my ability, put some of those dimensions into mine. But it seems like there would even still be some extra room, so maybe I can bring some coffee, like Tony suggested, because that sounds like a great idea.
And the one thing, I wanted to kind of ask, because each and every one of you, has at least provided a different perspective in terms of what it took to build all this hardware and how you all feel that we really pushed the boundaries in terms of making sure that this twin would go the furthest. I have a question for Mary Pope, Jonathan Pahed, and Tony. How would you each describe how the Artemis design processes have leveraged new manufacturing techniques for strategic affordability and sustainability of the overall system? We are here as this newer generation thinking of how is this rocket going to be different? How are these systems going to be different? And how are they extensible to all the future Artemis missions where we'll be bringing crew, bringing hardware up to cislunar and taking it beyond lunar? So if any of you want to share your experiences, I know you have lots of pictures there with you or with hardware. So I'd like to open that up.
Yeah, well, I'll start with Orion. So we're focused on sustainability in all steps of the process, right? So not just manufacturing, but also in assembly. I mentioned a little bit about our augmented reality capability that we've been using more and more throughout our final assembly. That example of reducing the crew seats from 8-hour assembly from 8 hours down to 45 minutes. We're trying to utilize that as much as possible, really reducing our labor hours by 38 to 90%, depending on the tasks. And so we can take that budget and that's time and put that into other processes, other steps, the next Orion vehicle, right? And we're also utilizing additive manufacturing and 3D printing. We've started with the drill blocks, and we've saved approximately $1 million, and we've gone from being able to produce those in several weeks to just a 24-hour turnaround, right? So we're constantly looking at new ways to make our program more sustainable.
Thank you, Mary.
So I could expand on that a little bit. Sorry, Erika, I could expand on that a little bit. So as I noted earlier, of course, we're using technologies where we can, not just Aerojet Rocketdyne, but obviously SLS as a whole. Words like affordability, sustainability, continuous improvement, those are all driven and are part of everyone in SLS as a whole. And we're of course, as well, as Mary noted, Aerojet Rocketdyne is leveraging additive manufacturing as well where we can. But we'll be taking the R-75 engine further than we ever had in new technologies as well, which will allow for the SLS core stage to push SLS farther than it's ever than any rocket's ever been as well. And those higher environments and whatnot, we had to leverage other technologies in order to meet those needs. You can't just take that engine and then say that you're going to take it to higher pressures and higher temperatures, because obviously that will increase weight on the engine itself. That will decrease capability of the rocket. So you have to take another look and implement technologies such as additive manufacturing and other manufacturing processes to meet the needs of the thrust levels that we want on SLS, but still meet the overall system requirements in order for us to meet the goals of SLS as a program as a whole.
Yeah, that's right. And you know, when you look at the core stage, the big orange section of the SLS, you see a lot of integration from the boosters going into the core stage, the engines on the aft end, and then ensuring all the integration for the Orion spacecraft. This is a human-rated rocket, and that approach, that level of requirements drives our innovation every day. Not just only from a systems engineering perspective, you know, we have model-based systems engineering approaches that drives the further efficiencies into not only how you build it. We have friction stir welding technologies, which make those welds really the strongest that we've seen in generations of human spaceflight vehicles. That's a big deal when you're talking about a human-rated rocket and you're, you know, sitting around the mission management team and saying, are you go for launch? That's that technical advances that we're integrating for that safety as a #1 goal here. And then thirdly, you know, we're not only looking at additive and investments in efficient telemetry systems, which are leaps and bounds from the previous twin, but also innovations into how we build it. Our machinists and technicians are truly some of the best in the world, and that workforce is looking at additive manufacturing capabilities to help drive further efficiencies in the build of these rockets. America, you have your rocket fleet and the things that we'll be able to do in half the time anywhere in the solar system. That's a big deal. That's innovation defined.
So I think Tony knew I was a SC&I person because he threw out the model-based systems engineering there, which I like. You know, I do like the going from full paper to using more techniques and modeling techniques, because doing the integration for something this big is a massive undertaking. The next question I have is for Caite Beck and Eric Weaver. You all are part of this new generation that's building these unique systems that haven't been developed since the Apollo era. Are there things you think about at night or stories that you wish for future generations to know about what this experience was like?
I guess I'll go first. So mostly at night, I guess I'm thinking just about how lucky and honored that I am to be working on a program that is so impactful and so meaningful for the future of space exploration and for the United States. What I would like to instill upon the future generations is to know that they should follow their dreams and their aspirations. And if that includes working on the space program, then by all means, go for it wholeheartedly and with all intent. And if they do want to work on a program such as this, that they should obviously work hard to ensure that they have that technical acumen, and that'll get you mostly there. But what's going to get you there, that final 10%, is going to be the passion that is evident in this industry. And I think that's very clear with this panel, even that there's a huge amount of passion that is powering this rocket beyond just the propellant that's inside of it. So I'm consistently just blown away by the potential that I see in our next generation of engineers and scientists. And I truly can't wait to see what they accomplish as we move forward.
And by the way, before you go, Caite, and we get to Eric, we did have a question here we may not have a chance to get to, but I want to ask you about your space hero, because you had something that, you know, share with folks.
Do you want me to answer that now, or?
Yeah.
Okay,
really
so yeah, so my space hero is Sally Ride, who most of you know was the first American woman to go into space. And I actually have a little Lego Sally that I keep at my desk. So to remind me, you know, what kind of trailblazers were there before me, and then hopefully can continue that legacy as we continue to move on.
Okay, and then Eric.
No, good. That's awesome. I love Lego and stuff. I have a civil structural background. So when I was like a kid growing up, Legos were my thing. And I think actually, you know, those types of like little toys and stuff, especially when you're a kid, like actually they can be kind of inspirational into like growing into your career. So I love seeing that type of stuff. But anyways, you know, I've always been just astonished at those guys in the Apollo program and all that they accomplished on basically slide rules and notebook paper and adding machines, maybe adding machines. I don't even know if they had that. And you know, as part of our job, we work on a lot of existing facilities at the Kennedy Space Center. So I've been exposed to a lot of different just handwritten calculation packages, hundreds and hundreds of pages from like the 1960s that are just like, you know, those guys were just remarkable. They were incredible people doing incredible things. And I feel the same way now, though. I mean, we have different tools. Like when I gave the example about the core stage, I mean, we made a full finite element model of the entire concrete floor in the VAB. And, you know, something that like those guys back then wouldn't even dream of. And so, you know, in looking forward, I would say, you know, future generations, like keep going, like look how far we've come with just like our analysis techniques and stuff. And then maybe, you know, someday 60 years from now, you know, grandkids and stuff will be poking fun at our, you know, dinky little models that we have today. So I think that stuff's awesome.
Thank you, Eric. And I know that I had so many questions that I really, you know, wanted to ask the group, but I know that we're running short on time. The last thing, and I wanted to kind of really keep it short, was for Caite and Mary. You know, if you were the first women stepping on the moon, what would you want her to say very, very quickly before I hand it back to Alan to wrap us up?
I'll go first. So if I was the first woman on the moon, I think what I would say would be, this next step of exploration, we take together as one people.
I like that. I like that, Mary, because it's very unifying. So I love that. And then Caite, what do you think you would say? I know it's a tough question.
Right. No, so this is an exciting question to answer because I actually have an astronaut app with NASA as well. So fingers crossed, okay. Maybe I'll get an opportunity. But anyway, honor those who have stepped here before me, and they will lead the generation of women that will follow.
Wow, that's beautiful. And I missed you for 1 minute. Is this something you submitted?
Oh yeah.
As part
yeah.
of Okay.
Mm-hmm.
And then Jim said I have another 5 minutes, so I am gonna try to squeeze something in here. So one thing just to know, at least for you all personally, at least I'm gonna ask this to Eric and Jonathan. What are you looking forward to on launch day, and where do you plan to be?
I guess I'll take it. So I watched STS 135, which was the last shuttle launch. I watched it right in front of the LCC. I think it's the second best seat in the house. Well, maybe third. I guess sitting in the vehicle is the best seat in the house. Mm-hmm. But actually, one other launch I watched from on the roof of the LCC, and that's like completely unobstructed, beautiful view. But you know, like, looking back to STS 135 and seeing that go, that was really special for me. And I think for Artemis 1, I think I'm probably going to stand in the same spot because I think that'll once again be special, somewhat nostalgic, and kind of like a handoff from like one to the other. And you know, looking forward to many more launches after that. So. And
one thing I'll warn you about the LCC, it's going to be loud. Yeah. A lot more thrust on the Space Launch System. So having watched the shuttle launch, yeah. Yep.
And when you're standing in front of it, the sound really like bounces off the building. Yeah, it really does.
Mm-hmm. And then Jonathan, since you're responsible, you and also the Northrop Grumman boosters, but from Aerojet Rocketdyne, Jonathan, where do you want to watch the launch?
Well, of course I want to be there in person. But likely I'll probably be looking at data, back in Los Angeles. But what I'm excited about is whenever you talk to someone that has spent their life and time in the space program, they have that glimmer, right, on something that they've been working on for most of their career, if not most of their lives, that they're just passionate about, obviously, right? I've been able to see my main combustion chamber in a hot fire test, and that alone was exciting and one of the most exciting things for me in my career. But being able to see something that I worked on for most of my career that will take humans beyond what we've currently ever been to before is something that I know that I'll remember for the rest of my life. And it's something that if you talk to anyone that's been in the space industry for a significant amount of time, they have that story, they have that passion in that story, and they're basically like telling you the story of an excited child in Christmas. That's the type of passion that everyone brings in the space industry, and it's hard to describe that feeling, but when you know that feeling, that's something you want to hold on to and have continuous experience on. So just that experience alone is something that I'm excited to be part of.
So I'll tell you what I like about your answer, Jonathan. Of course, all answers are right. But I started my career as an component engineer in turbo machinery for engines, liquid engines. And our first thing was always look at the data. We were there to look at the data, make sure everything went well, that the hardware was safe, that the vehicle was safe. So I love that you're sitting there waiting for the data to come back through the telemetry stream. And I know some people in our generation will actually be in the control center, in the firing room, waiting for all that data to come back, because the first and foremost is the safety of the hardware. So I love that answer. Thank you. And then from here, I'm going to hand it over to either Alan or Jim, since I know we're out of time and we ran a little bit over. I wanted to go ahead and hand it back to you all for a wrap up.
All right, well, Erika, thank you very much. We appreciate it, and it's good to see these younger engineers excited about what they're doing and learning about the history, taking the history and growing off of it and using it to inform and strengthen the future as we go forward. Thank you, panel. We really appreciate it. I do want to thank again our day one sponsors, the Aerospace Corporation, Blue Origin, and the Boeing Company, and our moderator, Erika Alvarez. Now we're going to take a break until 1:10 Central, 2:10 Eastern. You need to click on the next segment when you're ready to go. That will be at 2:10, and it'll be the Space Technology Award presentation. So all of y'all, thank you very much, and we'll see you on the other side of the break.